So hi guys, this is Yash and I'm the current Energy Club convener and I'll be talking about how do we actually calculate energy consumption before we move on to efficiency techniques. So how I'll be framing my presentation is that first I'll be talking about why do we actually need to care about our energy consumption. Then we'll talk about how do we calculate our household consumption and then some problem statements that Team Shunya and our Energy Club has for you. Moving ahead. So, 1 minute. So for the past year, our electricity consumption has been at about 1 million gigawatt hour, out of which 270,000 gigawatt hour is uh, for our domestic uses. When we look at it from per household consumption, it averages to about 90 units, which even if we, with our Mumbai tariff comes out to about 500 rupees on maximum. But we have usually seen that our bills reach north of 1,000 rupees. So we'll look into why it happens and try to reduce it. Secondly, there's also psychological behavior that's attached to it. For example, there's this case study where there were two houses. One had its electric meter behind the house, and the other had its electric meter situated near the door, where the residents could actually see how much energy they consume. So 1 month passed. The energy consumed by the meter which was placed at the door, they had a significantly lesser energy consumption as compared to the other one, because every now and then the residents were actually reminded of how much energy they consume, and thus they reap the monetary benefits of it. Moving on to how do we actually calculate energy efficiency. So it's a fairly simple methodology. First, we need to tabulate whatever appliances we have. For example, here I've got you a dummy table which mentions tube lights, ceiling fans, fridge, and whatnot. And we segment it into certain columns, right? So first is the watts consumed. Now, watts consumed is simply it's easily to get. It is mentioned on each appliance. For example, here you can see a Samsung adapter, which consumes about 54 watts, and then we write how many number of appliances we have. For example, our house consumes 4 tube lights, so we write 4 tube lights. Then the total watts consumed by our tube lights becomes watts into number of the tube lights we have, and depending on and how we calculate the energy consumed by tube lights is we multiply the number of total watts which we are using into number of hours. Now, number of hours has a specific meaning in fridges and air conditioners, which I'll cover up later. So this is the basic methodology of how we go about it. To mention this more easily, I have prepared a dummy table for you. Yep. So here you can see I had okay one. Okay, so I have these values. For example, the tube light consumes 20 watts, so I just tabulated it there. My house or any other house has 5 tube lights, so you just tabulate it there. And then we have, for example, if you see the tube light row, then we at the final left right hand side we get the total energy consumed by the tube light. Similarly, we go on for all other appliances and we get a total per day consumption of electricity. In fridges and air conditioners, there's a particular difference. For example, they don't actually have their energy consumption mentioned, but rather their cooling capacity and this energy efficiency ratio. Now, the stars you've seen on your fridges and air conditioners or any cooling appliances, they show how efficiently does it use the energy. Now, these watts are actually calculated by a simple formula, which is cooling capacity by EER. Now, EER stands for energy efficiency ratio. For cooling capacity is basically out of a given particular amount of air, how much heat can the device remove. That's our cooling capacity. For example, in this particular example I've got you, it its cooling capacity is almost 3840 watts, and since it's 4 stars, it stands for about uh, four. Its EER is 4, so we get about an wattage of 1100 watts. And there's also a term known as duty cycle. For example, if you're working a fridge for 24 hours daily, so out of 24 hours, it doesn't actually work 24 hours. Its compressor, which actually removes the heat, works a lesser time than than it actually does. For example, this duty cycle here, we have 30 years, 30%. For example, 30% as in out of 24 hours, only 30% of it will be used up to compress the heat. And thus 20, out of 24 hours, it adds up to 8 hours of usage, which gives us about 1200 watt hours of consumption. Now, since we got a daily consumption of 13.4 kilowatt hour, a monthly consumption becomes 402 kilowatt hour, which is significantly higher from our 90 kilowatt hour average. Now, 1 kilowatt hour is 1 unit. So thus we have a monthly consumption at 402.3 units, which is what we see in our meter. So now moving ahead to the actual billing part of it. So this is our usual Adani electricity bill which we get in a Mumbai apartment. I've boxed out the consumption part. So, and this is the tariff for our Mumbai appliances. Now, as you increase your appliance, as you increase your consumption, the the charges also increase, because the more you consume electricity, the more energy efficient you are not, or the less energy efficient you are, and thus they cost you more. So, for example, we got our consumption at 402.3 units. So, for every 0 to 100, every range of 0 to 100 watts, watt hour consumed, they bill it at about 3 rupees. Similarly, from 101 to 300, they bill it at about 6.02 rupees, and then for till 500, it's 7.15 rupees. And they also have the fixed charges per connection. For example, from 0 to 100, it becomes 65 rupees, and from 101 to 300, it becomes 105 rupees. And then our net billing comes out to be about 2,000 rupees. So that's high from what we actually seen. So this is why we actually this is what gives us the indication that we actually need to take a look about how we consume our energy and where we can make it lesser. So we have done with that. So now simple tips to reduce our housing consumption is that we replace our existing models with some energy efficient models. For example, for example, LEDs and CFLs are more efficient than the usual tube lights, cathode tube lights. Now, also in fans, we have new DL-DC motors coming up, which are way efficient than the usual induction motor fans. Similarly, we can use energy-intensive appliances, as I said, and also it becomes more inherent to us is that we start using lesser electricity, and we become more vigilant about it. After that, we had these problem statements prepared for you. Uh, there are 3 problem statements from our side, which we'll be asking you to do, and you'll be giving us the solutions through Google Forms. And then the 3 top writers will be uh, shortlisted and showcased on our Insta handle. So these are the 3 problem statements. The first problem statement showcases how the disparity between a US flat and an Indian flat, how much energy it consumes. The second talks about a rural and an urban household in India, and the third talks about a flat and a bungalow's consumption. So you'll be filling out any of the 2 statements from above, and you'll be filling the Google Forms to us. So thank you for that.
Yeah, thank you, Yash. So the problem statements Google form will be entered in the chat box in 2-3 minutes. And now moving on, Ankush, a PhD research scholar member of Team Shunya, will be speaking on the mechanical point of view of efficiency techniques. So over to you, Ankush.
Yeah, am I audible now?
Yes.
And my PPT is visible?
Yes, it's visible.
Yeah. So welcome all of you. And in continuation to what Yash has explained, that if we are consuming energy more efficiently, we will get least bill, and simultaneously we will be more efficient in cost, in the way of cost as well as in the way of sustainability. So how can we reduce these energy consumptions in our house? So Team Shunya work on that particular thing to reduce the energy consumption in a house, and we will try to explain some of concepts from Team Shunya's work. So the content of my presentation, not presentation by me alone, me and Renuka, will be the energy consumption in heating and cooling loads, which are the basically important loads in our house. Second, reducing the these important loads, heating and cooling loads, and then we will try to explain some methods, renewable and new methods, which are currently available in market to reduce these loads or to replace these loads by more efficient way. So first is energy consumption in heating and cooling. So where we required heat in our house and where we required the cooling in our house. So this slide explains the some of these concepts. So where we required the cooling. In case of cooling, if we say whatever be the energy, heat energy inputs to the house or the room, that will increase the temperature of the room. And as we know, for a normal human, to maintain the productivity, we require the temperature nearly equal to 24 degrees Celsius. And if you have to maintain the temperature of the room, we have to extract the added heat from the room itself. So how what are the ways through which heat can be added or heat gets added to the room? So most important part is the external part, and second part is internal heat sources. So in external part, the main source is solar energy. So solar energy or solar radiations which falls on the roof or the walls will will get absorbed by the roof and walls, and this heat energy will obviously get conducted or and convected to the internal room, and that will cause the increase in temperature of the room. And to maintain the temperature, we will have to extract that particular heat. Next part is in direct solar radiations through various openings in the walls. These are from architectural point of view, these openings are called as fenestrations or the windows or doors. And the solar radiation which is directly coming from these openings are the important source of such heat. And the third important part is infiltration. Infiltration is the energy which is carried in by the flowing air, which is passes through the cracks in between the walls or the between the windows. So that kind of energies are uh, added from the external sources. And if we consider the internal sources, so there are various devices running like lights, electronics, computers, TVs, and those will cause the heat addition to the room. So those kind of loads are called as sensible loads. And there is second kind of load which are not only adding the temperature rise but also adds the moisture rise in the room. And in case of climate, moist climate like Mumbai, we will have to consider that particular part as also importantly. So those are like human respiration, the steam generating devices, those add the moisture as well. So we have to remove moisture as well as temperature or heat, we can say. And next part is what are the heating loads or where we require the heating in our house. So most important heating load is in the cold climates, where we will have to maintain the higher temperature as compared to outside temperature, where the outside temperature may falls down below sub-zero temperatures also. So that is one important heating load. Next is domestic hot water requirement. Throughout India, whichever may be the climatic condition, it is the domestic hot water requirement is there. And from the various clauses of green building constructions, we will have to supply at least 20 liters of hot water per person per day in a house. So that kind of hot water requirement is generally expected in a house. Next, heat requirement is for the cooking, and that cannot be eliminated. So these are the heating and cooling load requirement which we have to tackle. Now, how can we tackle these particular loads? So first way is to reduce this particular heating and cooling loads, and second will be by changing the by changing these particular things, loads towards the renewable technologies. So first we will see how we can reduce the heating and cooling loads by passive techniques or optimum utilization of devices. One of the way is explained by the Yash, that we can use more efficient or more devices which have higher star ratings, energy efficiency rating. That is the most important way, but there are other ways also, so we will see one by one. So first is passive technologies. So what is passive technologies? If we see, passive means something which does not add any additional work, requires any additional work. So from this we can say that passive technologies are the technologies which can maintain the required temperature in our house without any additional work input from electrical devices or from mechanical devices. So how this can be happen, or how this can be achieved? So most important part is building orientation. By just changing a building orientation by some angle, we can reduce the amount of solar radiation falling on the walls or the roofs, and that can increase or decrease the solar radiation. In case of cold climates, we will have to maintain the orientation in such a way that we will have in such a way that, am I audible?
Yes.
Someone, yeah. So in cold climates, we will have to maintain the orientation in such a way that we'll get maximum solar radiation, so that the heat requirement can be reduced. And in case of hot climate, we will have to maintain the orientation such that we will reduce the solar radiation and will reduce the cooling requirements. Next is roof extensions, which are mentioned in this particular Sustainable Sunday poster by Team Shunya, which are such kind of posters are posted by Team Shunya on various media platforms. So here what we are doing is that we will increase the roof extension by some angle, and that will cause the shadow on the windows. That shadow will be that particular extension will shadow the windows during the high sun time, means in the evening, or we can say in the summer time. But in the morning or in the winter time, these extensions will allow the solar radiation to enter in the house. So that way we can allow sun when it is needed, and we can block the sun when it is not needed. So that kind of passive techniques can be adopted in a house. Next is cross ventilation or natural ventilation. It is the simple way, like if our AC is switched off or fans are not working, we will just open the windows, and that particular flow of air will maintain the air temperature to required conditions. So that is the one way, easiest way to maintain the cooling, to reduce the cooling requirement in a house. Next is, there are various advanced technologies in the building construction itself. Like there are some insulating materials which are used in the walls. We can add those insulating materials, and that will reduce the heat loss from house to environment, or from reverse, environment to the house, and that can reduce our requirement for heating or cooling. That can be incorporated in the building construction itself. Next way is energy efficient window glasses. As we say, so direct solar radiation from windows is also one of the important cause for heating load. So if we are using the double glazed or triple glazed glasses, which are just, instead of single layer, 2 or 3 layers of glass with some vacant space in between, that will increase the resistance to the heat transfer, and that will reduce our heat requirement or the cooling requirement. Next is cool roof paint or coatings. That is also one innovative idea on which there are tremendous research is going on, and this is actually practically implemented in some of the cities in Rajasthan and Gujarat as well. So this kind of paints, what they do is that they will reflect the maximum amount of solar energy from the roof, and reduce the amount of energy absorbed by the roof or the walls, and that way we can reduce the cooling requirement. We will explain this particular technology in details in the upcoming slides. Might be Renuka will explain it. Next part is optimum use of devices. So what is optimum use? The optimum use means we can operate the devices at maximum possible efficiency. If we see that particular labels, energy efficiency labels, those will mention some values of operating conditions. If we operate these particular devices at that particular conditions, those will give the maximum efficiency. Like our ACs or the refrigerator ACs, take example of ACs. Operate if we operate them at 27 degrees Celsius, they will work with maximum efficiency. And if we reduce the temperature to the 18 degrees Celsius, that will operate with lower efficiency. So one can say by reducing the temperature, we are reducing the time required for cooling, but we are reducing the efficiency of the cooling as well. Even though we are maintaining the same cooling effect, we are doing that particular thing at lower efficiency, and lowering the efficiency means we will have to add more energy for the same cooling effect, so that if you cool something at 27 degrees Celsius, that will be more efficient. Similarly, in case of refrigerator, if we try to create the ice or freeze something in just minutes, 30 minutes or 45 minutes, that will consume more energy, because that will be less efficient. Instead of that, if you do that particular thing in number of hours, that will be more efficient way, and that will consume the less amount of energy. So that particular things has to be taken care while operating any devices, electrical devices. Next part is energy efficiency of appliances. As explained by Yash, the energy ratings are available on the devices. But if we see normally the market, higher efficiency means higher cost. That is the normal way we think about. But if we see the long-term cost of these particular devices, we can conclude that the energy saving by higher efficiency will be the more than what we are paying for this particular device. So using high rating devices are the one of the important way to reduce the energy consumption. And next is using the recently rated appliances. If you are using the 5-star device rated in the 2020, and if you are using 5-star rated device rated in 2018, there will be at least 50% energy reduction, energy consumption difference in between these two devices. So most recently rated devices will be more efficient and highly rated. So that is most important part while considering the power savings by the energy ratings. And these are the all technologies or all things which we can incorporate by our day-to-day life by just changing something. But there are some technologies also which are some which require some additional cost, and by that we can work on it. So Renuka will explain about those in details, like renewable and new methods for heating and cooling. Renuka, hello, am I audible?
Yes, you are audible. Renuka, I think she's not in the meet.
Okay, so no issues. I will continue with the same.
Yeah, okay. I'll
So
try
is there
contacting her, and you can continue, and then I'll try contacting her and see if like what happened.
yeah. And is there any time issues? Means how much time there is remaining? I will take just 10 minutes more if allowed.
Yeah,
That's
there's
fine.
no. Yeah, that's fine.
Yeah. So first is solar thermal. The most important heating requirement in our house is for hot water requirement or the cooking requirement. The solar thermal is the way in which we can replace this particular heating requirement. And the solar cooker is one way where is the thing in which we can replace the cooking technology or cooking requirement. So here I have tried to mention the commercial part of the solar cookers, because we don't think that solar cookers are that much commercially feasible. So they are feasible means if we are using them very frequently, the cost of solar cookers can be recovered in couple of years, and those will after that those will be free of cost. So that kind of free energy which is available in the our backend, and we can use it whenever we want. And the next part is it doesn't require any much innovations as well. Like this particular Parvati cooker which is mentioned here, that is developed by a house by a couple in Pune, who is not that much educated in engineering background, but from the household material they have created their solar cookers, and that can create temperature up to 250 degrees Celsius as well, and that too in lower cost. So these kind of devices are available which we can use. So in all markets, Indian market as well as international market. Next is solar thermal for solar water heating. As we see that if we are considering 20 liters of hot water requirement per person per day, if there are 5 persons in a house, there will be 100 liter of hot water requirement per person per day. So if we see the cost of 100 liters solar water heater, it is something like 15,000. And if you see the energy savings throughout uh, the energy saving for the heating water requirement, that can be recovered, that cost can be recovered in couple ranging from couple of years to the 10 years as well. Like in the some cities in India where the solar radiation is much less, in that case we will require more number of years. But there are some cities, like some regions like Gujarat, Rajasthan, Maharashtra, Delhi, those parts where there is abundant amount of solar energy and solar days are available. In that case we will not require any additional heating water requirement. So that way we can recover this cost of solar water heaters in couple of years. Like here we can say, here is for Delhi it is 3.9 years, and for Pune it is nearly 4 years. So that will be recovered. After that it will be free of cost, and the lifespan of such water heaters are ranging from 10 years to 20 years. That will depend upon the manufacturers and technology which we have used, but that will be free of cost. After first 4 years it will be free of cost for the remaining all years. And there are much detailed commercial studies available which we can you can go through from the references if someone needs more technical details and commercial details as well. Next is what are the these are the heating technologies, but what about the cooling? Can we replace the cooling with more efficient way? So yes, there are some solar PV refrigeration technologies which are available, but they mainly use the solar PV panels and use that particular generated electricity to run our regular AC or refrigerator. So that kind of normal innovation is adopted there, and that will reduce your electricity bill. And next way is solar thermal refrigeration. It is widely used in the commercial or industrial market right now, but in domestic market this technology is getting developed slowly. But one day we can hope that this particular solar thermal refrigeration technology will be available for domestic small scale market as well, and that will be the more efficient and cost efficient way, we can say, as compared to solar PV refrigeration, because the requirement of cost is the solar PV panel. Solar PV panels are removed, then the cost will be reduced, and that will be the more cost effective way. The more cost effective way and the practical way available for cooling right now is the evaporative cooling technologies. If we are living in the hot and dry climates like Rajasthan and Gujarat, or some of the cities from MP, then we can experience that during the summer time by with reducing the temperature, we also have to add some moisture in the air. Due to this, the availability of less moisture, there are some issues, skin diseases also there. So to maintain this moisture requirement and temperature requirement, both can be done with the help of evaporative cooling technologies. And there are number of commercially available domestic as well as industrial evaporative cooling technologies which can be used or which can be accommodated in our house. That will reduce your requirement, electricity requirement, as well as that will be the more sustainable way of cooling in hot and dry climate zones. Next is radiative cooling technology, as explained by me in the previous section. Radiative cooling is the more developing technology. We just see that we can put the reflective coats, paints on the roof, but there are some paints or the some techniques or some panels are available which can cool the water or cool the air below atmospheric temperature as well with the help of radiative cooling. In that particular case, what they do is that instead of receiving the radiative energy, they will emit the low temperature, low wavelength emissions from the panel itself, and due to that emission the temperature will keep on dropping, and that technology is easily adaptable in the climates where there is clean sky. So that kind of technologies are in development and are more energy efficient and can be adopted in the house to reduce the cooling requirements. So these are the some of the technologies which on which Team Shunya is working, and for such more technologies we keep posting such posters like Sustainable Sunday posters on our media platforms. So just go through them, and we are working on such technologies. If someone wants to collaborate on such technologies, you are welcome, or we can discuss on those things. Okay.
Yeah.
Yeah. So actually passive cooling technologies are adopted during the construction itself. Means while calculating the energy saving by passive technologies, we will have to check the energy reduction, not the actual energy consumption, and after that how much amount of cooling we are providing for that particular technology. That cannot be adopted. What way we have studied is that we will first calculate the energy consumption for normal building, then we will apply some passive technologies to that particular building, and then we will again calculate the energy consumption for that particular building. So there are softwares available where we can do such modifications, passive technological modifications in our building, and calculate the energy consumption throughout the year, and that can be done. So
Okay.
there are methods or softwares which can be used, but that will be a detailed session which can be conducted by someone who is expert in that particular thing.
Okay.
That is used in architectural point of view. Yeah.
Oh, okay. And the second question is, do energy conservation at home and smart homes go hand in hand? And if yes, then how?
What if who has asked that particular question, he can explain what he mean by smart homes. That will be helpful.
Okay.
Yeah, if there is no one, so I will just continue. If he is talking or he or she is talking, smart homes means the homes which are adopting the smart technologies, smart devices which are used. So that is possible, means smart devices, using smart devices in the house, that will be the more energy efficient way. Like if you are having a smart fan or smart plugs, smart lights which can sense your present. There are smart ACs as well which can sense your presence, and those will reduce the energy consumption based on your presence. So just a couple of days ago I have seen one advertisement where there is AC which will adjust their capacity from 1 ton to 3 tons depending upon the number of persons present in the room. So that kind of technologies are uh, really helpful in the energy efficiency kind of things.
Okay. And a question from Madhu Ganda Kolhe is, what kind of passive techniques should be used in a city like Mumbai?
Yeah. So actually I am from mechanical point of view, so this question can be better answered by an architectural person. So I will not comment, not that much confident about commenting on this question. So just
Yeah, that's fine. And the last question, how to determine the parameters in energy usage?
parameters means,
Like measurement parameters, I'm guessing.
yeah, as Yash explained that if you are calculating the energy consumption of house, you will just have to check the wattage of particular device and the time required for running that particular device. That can be easily available on that particular device, and using these particular two parameters we can calculate the energy consumption by that device. Or the simplest way is by looking at our energy meter. So our energy meter will give us number of different parameters, like how much amount of load is connected to the that particular load is connected in that particular house, what is the total current flowing, what is the actual voltage at that particular point. Those kind of parameters are available in our energy meters, which are connected by our distribution company. So those parameters can be done. But for detailed study, there are different energy meters which are available, which energy auditors use in large scale. But in small scale, those kind of devices or those parameters are not needed at much.
Yeah. Okay. So,
Yeah.
yeah, I think that's the end of all the questions. And Renuka actually had some network connection problems, so she couldn't join the meet, but it's okay, you covered up everything. And yeah,
Yeah.
so it was a great session. We got to know all about how to calculate the residential consumption of energy, as well as the mechanical and electrical points of view to improve the efficiency. And yeah, so it was very interesting topic. And as for us engineers as well, like, it is a great topic to like think about, and we think on ways to improve the efficiency of houses. So I thank all of the speakers for giving their time and uh, speaking on the topic. And yeah, if anybody has any further questions, they can reach out to the speakers. Yeah. So yeah, is that all, Ankush?
Yeah, from our side it is fine.
Okay.
If someone has questions, he can post in the chat box, or he can go through the our team Shunya or Energy Club, can reach out to team Shunya or Energy Club by various ways, and he can
Yes.
ask any questions or doubts, or how to interact with team Shunya or Energy Club. You are always welcome, all of them.
Yes.
So it will be an interesting activity to participate in.
Yeah. And the problem statements
Yeah.
have been provided in the Google form itself, which is in the chat box. So the people who are interested can fill them in. And yeah, it's a nice activity to get to know how different situations are compared. So yeah, I think that's all. Thank you to all the participants for joining. Yeah, and I'll end the meet now. Thank you.
Yeah, thank you.